Generative AI is reactive by design. You provide a prompt, the model predicts the next string of text or pixels, and the process ends. The technology effectively stops working once the file is generated. Agentic AI changes that relationship. Instead of micromanaging every response, the human provides a final destination. The system then independently determines the individual steps required to reach that goal. It is easy to mistake an AI agent for a slightly more capable chatbot, but the large language model is only a component. It functions as the cognitive core, the brain, nested inside a broader software architecture. This surrounding structure allows the system to take a master objective, decompose it into subtasks, and select digital tools to execute those tasks without human intervention. This shift turns AI from a static generator of text into a goal-directed digital worker that interacts with and modifies the real world. This diagram shows the control loop, the core engine of an agent's autonomy. It is a continuous cycle of planning, acting, and evaluating results. In the policy layer, the LLM reasons over the goal to formulate a structured plan. It doesn't just guess the next word, it identifies the necessary dependencies to complete a job. To maintain consistency, the loop is constantly retrieving context from the memory layer. It balances short-term working state with long-term semantic storage, ensuring the agent doesn't repeat its own mistakes. In the tools layer, the agent translates thought into action. It moves beyond text and begins interacting with external APIs, writing and executing code, or querying live databases. If the agent attempts to book a flight and finds the seats are gone, it doesn't crash. It observes the failure, loops back to the planning node, and recalibrates its approach to book a train instead, all without waiting for a new human prompt. This iterative feedback loop creates a resilient system that can navigate roadblocks independently. As tasks grow into enterprise-scale workflows, a single agent can become overwhelmed. Its context window gets cluttered, and too many available tools leads to decision paralysis. To handle this complexity, architects use multi-agent systems to distribute the cognitive load. In an orchestrator-worker topology, a central manager receives the primary goal and delegates subtasks to specialized subordinates. Instead of one generalist model doing everything, work is split between a researcher, coder, and QA tester, each operating within their narrow expertise. These workers cross-verify each other's outputs. The researcher's data is formatted by the coder, then audited by the tester, before a single refined result is sent back up to the orchestrator. This structure mirrors a professional organization. It allows for modular testing, ensuring a failure in one specialized area doesn't bring down the entire operation. The result is an ecosystem of digital experts that pool their capabilities to achieve results that exceed the limits of any single model. Granting an AI system the authority to execute real-world actions significantly increases the stakes of a failure. In a generative system, a hallucination results in an incorrect sentence. In an agentic system, that same error could lead to the autonomous deletion of a database or the authorization of an incorrect wire transfer. This architectural autonomy creates a novel security risk called prompt injection or goal hijacking. If an agent processes a document containing hidden malicious instructions, that untrusted data can be interpreted as a new command, overriding its original goal and forcing the agent to execute a harmful action, like exfiltrating your private emails. Because the agent is already authenticated with real credentials and API access, it has the functional power to carry out these hijacked objectives instantly. To deploy these systems safely, developers are forced to implement strict governance layers, like least privilege permissions, secure air-gapped sandboxes, and mandatory human-in-the-loop approvals for any sensitive action. When the AI handles the execution of 1,000 substeps, the human role changes. Instead of manually clicking through software interfaces, the user's primary value shifts to auditing the final gate. This architecture moves us toward a future where we no longer operate software, we supervise it. The technology can execute our intent at a massive scale, but only if we are willing to oversee the autonomous systems we've built.